Wow, that's quite of a crowd. Thank you all for joining this session. To trace some problems that can be hidden inside your Java program. My name is Victor. I flew this morning from over here. Okay, so I'm coding in Java for almost 20 years, and for the past 10 years, I'm doing consultancy and coaching for various teams for an insane amount of companies throughout Europe. Insane as in unhealthy. You can't imagine the horrors I've seen. My favorite topics are refactoring, architecture, and unit testing. So if I would define myself, I would define myself as a clean code maniac. Of course, I do Java stuff, Spring Framework, Hibernate Performance, Reactive. And I lead the largest community in the world focusing on software crafting, which technically means how to write code that they won't hunt you down afterwards. Okay. It's free to join. It's on Meetup. It's in English. It's on Zoom, on YouTube, meeting every month to argue about various topics. And I literally mean argue. I never present and that's it. No, there is always a discussion, very heated discussion with very smart people, much smarter than me, for sure. Good, and the events are also recorded on my YouTube channel. And because life is more than just work, I have a lovely wife, 2 kids, and a cat. The cat is the problem, really, in this picture. Anyway, so just one question to start. Have you ever told anyone this code probably has a performance issue? Have you ever optimized code before measuring where the problem is? That's why I'm here. Okay, so you have your response time is too slow, it's too long. Congratulations, first of all. It means you made it to production. It means you are taking serious load. It means you may be useful to someone. Congratulations, but then how do we start? We're going to basically go through 3 levels of finding the bottleneck. We're going to go outside in to see the tools. Many of them you're going to recognize, but the focus will be in the profiling, of course. But let's start from top to bottom. First of all, imagine this is your microservice ecosystem, and you are here waiting for A to respond, and A is waiting for B to get a message on a queue from D, which is waits for E, and which is hang in a query in the database in which there's a deadlock with someone else. Congratulations. So the first problem here is to trace the request, how it goes through the many systems it went through, right? Who here is doing microservices? There you go. So, yeah, this is for you. So the first problem is to be able to track down requests as they move from system to system, right? Do you guys know what this yellow thing is? What is this? Trace ID, exactly. It's a number that propagates magically from one system to another, right? And I want to spend 1 minute to explain this, because maybe not all of you are familiar with the concept. All the systems involved in such a flow have to share the same trace ID. Now, this trace ID is generated by the first system in the chain, probably the API gateway. Then, if you are not in the API gateway, but in B or C or D, you're going to receive the trace ID in a header, in the message, in the event, or in the HTTP request that you receive. And the good news, they are standardizing this, so you can interoperate Quarkus with Spring, with .NET, with these headers get standardized. Now, trace ID, the magic thing in Java at least, is that it propagates magically with your method calls. And that's quite mysterious. How the heck can I call another method, and without passing any argument, the trace ID moves along? Anyone knows how this works? Actually, it's on the slide. Sorry. It's a thread local. It's a magical variable that moves along, and if you are unfortunate in doing webflux, it's reactor context in your case. But the important thing to remember is that every time you change the thread, you need to do it with some mechanics injected by Spring. You can't just start a new thread because that thread won't have this metadata. You have to submit into a Spring-injected, Spring provider executor. You have to decorate the executor so that metadata is copied in the child thread, right? And once you send the request or a message outside, you need to be careful again to use some Spring decorated mechanics or whatever framework you're using that will take from the thread and put it in the header. This is the stuff that we have to care about when we code, right? There is, of course, infrastructure around us, but this is something you need to remember, right? Now, so we have this trace ID moving through systems. And then the next thing we want to do is to measure how much time each of these systems spent working on that trace ID. And we define this as a span. And then all of our systems are going to report these spans to a central system that is going to track where time got lost. Okay? Of course, if you report every single request, you're going to kill performance by reporting, basically. So you have to report a sample of all the requests. Okay? I just described the Zipkin, basically, here. Right? So this is a trace ID that moved through a series of systems. Can I zoom? Yeah, perfect. Service 1 called service 3 called service 4. How cool is that? And this is the span that service 4 took to complete that request. And you can see this is waiting for a response from over here, which is waiting from it's a child play to interpret this, isn't it? It's super easy. And I know teams in microservices that use this to make a hole, to understand where their requests go. Because they forgot. They have so many microservices, they don't know each other exactly what happens. This provides the perfect tool for an overview. And this can also show you very fun things. For example, I'm getting the product, and then this calls get product details, get recommendations, and get review. But the fun thing is that these requests don't depend on each other, so why am I doing them in a sequence? What can I do to optimize this flow? Exactly. Parallelize, right? Fire them in one go, right? So you can detect many performance anti-patterns in distributed systems. For example, and I'm not shitting you, I met in 2 clients, accidentally repeating the exact same request in the same. They were firing the exact same request twice. Why? Oops. Legacy code, macro service. Or calls in the loop, you do 4. You have a list of IDs and you want to get the orders. 4. You do 4. God damn it, no, right? Batch fetch them, right? System in the middle, you go through an intermediary system for no real reason, right? You could just bypass B, right? Or A calls B, calls C, calls D, every time paying a network on all of these arrows, right? These are anti-patterns in distributed computing. You need to avoid these. Or the stuff you said, compact. Good. But imagine you find a span which doesn't wait for any other downstream system. That probably is the guilty one. So you want to zoom into that system to see what you find about that. And I want to bring back a bit high school time. Do you remember how we used to measure time in high school? You don't, huh? Yes! But now we are professionals now, we have logging, so we log before and after, and you look at the timestamps, right? Brilliant. That would trash your log, of course. So for that reason, we want to do something more professional. So let's use some magic for this. We put timed on a method, and that method gets automatically weaved by an aspect, by intercepted, and measured how much time it took, right? And you can put this annotation on any method that does any suspicious things, like API calls, like DB queries, like CPU-intensive parts. You want to keep them tracked, keep them monitored, right? And then if you go to Active Prometheus in a Spring Boot app, who here is using Spring, just to have a clue? Like 70%. If you second count, it'll tell you how much time that method took to run. Okay? And you divide, you get an average. Congratulations, you put it on a chart and you impress your boss. Good. 5 seconds later, you go again and you fetch them. And the new numbers are the red ones. You subtract the blue ones and you do the average again and you plot the new time, which is basically the running average, what was the average execution time per the last 5 seconds. Make sense? And that could be a spike. I mean, it doubled from before. What the heck is happening in here, right? Good, so what really happens there? You have put annotation, and there is an interceptor that captures your call. And it can do very fancy things. Ever heard of, who here has heard of percentiles? Percentiles, excellent. So 95% of requests finish before 100 milliseconds, right? But every time you use aspects and magic, I want to warn you that these annotations, in general, in any DI framework, work only on methods that are on beans that are injected by the framework. The method should not be final nor static. So this magic comes with some tricks, plus the fact that the actual aspect can hurt performance. If you put it on a method that by default takes less than a millisecond, the aspect itself is gonna hurt performance. So if you want to avoid the magic, you can do timer record, shovel the lambda in there, or report the time. You can count how much money you earned that day, and you can keep track of how many players are currently playing the game. These are the things you can do, the basic things you can do with Micrometer. Make sense here? All good? All good. Right, so these metrics are then exposed, along with many other standard metrics from the frameworks. And the fun thing is that every time some team had a performance issue, every time the frameworks observed their users, the projects using them had some issues, they were kind to us and exposed the metric so that we can look exactly about the problem. So any recurrent issue in a framework is currently exposed probably as a metric already. So these metrics are collected and stored by Prometheus, and then maybe Grafana, just some names, presents these in some impressive charts. And yeah, you can put alarms. You can get woken up in the middle of the night because some metric got too high. Of course, there are many other paid solutions. Some interesting metrics that the goal here basically is to break the myth that performance bottleneck finding is something mysterious. No, friends, it's super easy. Just have a look. Because there is a lot of mystery around this topic. Oh my God, it's hard to measure. Not quite. Look, request second sum and count. How much time this endpoint took to execute? Simple, automatically exposed. How much time, how many connections are open with its clients by your Tomcat, and how many threads are currently working, which means 98 of your requests are sitting there waiting for other requests to complete. That's known as a thread pool starvation issue. How can we fix this? Not web flags, death to web flags, no. No, add more threads, kill threads. Folks, hello, Java 21, virtual threads. It won't be 200, it won't be 20,000. Cha-ching, right? Done. Death to the web flags. Good. Usage after GC%, if you have more than 30% memory occupied after a full GC, you may have an issue with having too little memory. You might want to increase your memory. Depends on the GC algorithm you're using. How many time it took you to acquire a connection from GDBC connection pool? That's in front of you here. It's 150 milliseconds waiting time for every single request that wants to hit the database. That's a GDBC connection pool starvation issue. I'm going to try to demonstrate this today with you. Cache miss of 99%, something is fishy. Your cache doesn't do anything. It's 99 missing, plus your own metrics. Okay? So these metrics you get for free. You just have to look for them, basically. It's already there. They're already there. So I'm going to claim that basically finding the common performance issues in one system should be done by now. But maybe not. If looking at the metrics can usually point out more than half of the issues that are happening in your system. But if they are not already a metric, once you fix the performance bottleneck, then you have to expose a metric and put an alarm and put it on Grafana to keep monitored because you want to prevent it from occurring again. Make sense what I'm saying? Once you fix a performance issue, leave behind, just like we leave a unit test behind fixing a bug, we will leave a metric and an alarm and a chart in Grafana after we fix the performance issue today. Okay? But if the bottleneck does not happen in code which exposes metrics, for example, in a dark library or in some legacy code that you don't have a clue about. In that case, you can't really use metrics, so what can we do? One naive idea would be to measure the execution time of every single method in the JVM. And let me tell you what some geek can do one day. Can instrument your JVM with an agent, and you can literally do that. You can literally intercept every single method call in your JVM. Don't ever do that, please. You're going to blow up performance, right? Every single method call is going to... That's not feasible, really. You can't intercept all the method calls. I'm not talking about Spring. I'm talking about much more dark magic. Much darker. Much more dark. Something evil. Good. Don't go there. Instead, use the profiler, which is built inside your GVM already. It's called Java Flight Recorder. Who here has heard already about GFR? Ah, yeah, less than half. Good. These are the tools of the gods. They use GFR to optimize how the GVM works. So what does it do for us? First of all, it's free. Yes. Secondly, it records some very, let's say, low-level GVM events. One of the most interesting will become soon the pinned virtual thread. I don't want to go in there right now, but virtual threads are not, they have their own issues, which you can trace very easy with Flight Recorder. Right? And you can also click here to see how you can expose your own events using GFR. But that's not what I'm going to talk about today. I'm going to talk about the other feature in GFR, which is to capture stack traces of all your running threads every second. And these we're going to refer to as samples. So there is someone taking a snapshot of what your application is doing every single second. How is the name for that? Stroboscopic light, I think? You went to disco, and there is pictures, right? Every second, and you're going to see if one guy is always in this position in your pictures, then you know who got drunk. Probably a bad example, but anyway. So this is what I'm going for. And very fun feature about GFR, probably the most important feature. By design, from the beginning, they aimed to be able to run this GFR in production. So the latency, the overhead that it adds to your program, they brag to be less than 1 or 2%. So you can literally keep this in production open at all times. If you search GFR talks, that's what they always say. That's the author of GFR saying this, with the default settings. I'm going to skip this. It's boring. It's how you enable GFR. The slides, you have them already. And if you did not have them, Twitter, I posted them half an hour, 1 hour ago. They're already there. So the next 34 minutes, I'm going to try to walk with you through how do we read the output of a profiler. And let's start with a very simple example. It's dummy method here calling entry calling f and g. F takes 2 seconds, g takes 4 seconds, of course. Sleep, what do you think? Of course. And if you run this program, imagine someone takes snapshots every second of the running program. And the first snapshot, it captures f running. And that stack trace, as usual, we read it from bottom to up. It goes dummy, calls entry, calls f, calls sleep. I believe all of you had an exception before, right? So you know how to read stack trace. Good. And f is surprised on with drinking. And then g is also surprised. How many times does g get captured? How many times do I see this trace? 4 times, right? So I'm going to see 4 times that one, 2 times the other. And if I do the relative percentage, I can claim that 33% is lost on line 17 and the rest on line 18. Makes sense? Based on samples, you can infer a bit where time gets lost. Now, to visualize this better, the bars are sized according to the number of samples, right? And next step, these two here are merged together. If they are the same, look. 14, 14, merged together. Done. You have your flame graph. Now, inside this flame graph, what we will be looking at very soon, it will be split points. Points in which the execution takes one side, this basically forks onto, right? This is the interest point when studying a flame graph. Okay, now, this is like a didactic example. Now let's see real life. Real life, there are 100 method calls of stuff you didn't ever hear of here, 50 more here, and then at the end, some mysterious thing called park. What the heck is that? I'm parking a car? What the heck? And here, socket reads 0. So you're going to go very deep down the rabbit hole here, looking into the basically X-raying your application, right? You're going to see all the bones in the hand, the 20 bones in the hand with this. Good. And there is one more problem. There is one catch with this. Any kind of sample-based conclusion, including the effects of the COVID vaccine, had to be proven on a sufficiently large lot. Make sense? You can't draw a conclusion by looking at 2 samples there, 4 samples there. Please do not ever draw a conclusion comparing 2 with 4. Because it could just be lucky. Maybe if you run it much more times, maybe the 2 would remain 2, but here there will be 400. You don't know. It's too little sample. You know? So because it's sample-based, you want to have a lot of samples. How do we get that? Either with heavy load tests or running in production. Keep it open for 1 week and see what it says. Okay? Right, so we're approaching the experiment, so please let me introduce you to the parties here involved. Ever heard of Gatling? Interesting. K6? Few. JMeter? Everyone? Yes, thank you. Anyway, it's a load test tool which will fire 23 parallel requests on a Spring Boot 3 application. Good. Now, this application would go through to a wire mock that I carefully instructed to respond with 40 milliseconds delay. And that's also fun by itself. Let me show you how I do that. It's very hard. You have to work a lot to do this. I mean, I was barely able to do this. So hard. The real problem, however, was the Postgres, which, of course, I ran locally in a friendly Docker. The problem with the Postgres running in a Docker is that it's too fast. The network latency is 0, you know? So what I did to emulate a real life on my machine is added a toxic proxy, a magic, this is from Shopify, yes, which is able to poison the network by delaying packages and losing packages. I think it's called chaos testing, something like that. Yeah. And basically, I'm driving my JDBC connection through this guy, running, of course, in a Docker, to add 3 milliseconds network latency. It's all in the README, it's all in the Git. You can, in theory, you could clone a run and it works. In theory. And if the theory doesn't meet reality, email me, I'm going to help you. Really, I'm not kidding. If you want to repeat the stuff I do today, you can always contact me. Java Flight Recorder runs in the JVM here, and I'm using a very mysterious, stupid tool called Glowroot. Anyone heard of Glowroot before? Glowroot? Few people, 2 hands. What the heck? Don't use it. It's just for didactic presentation of. In practice, we use other tools, of course, much more professional. This is like. It's not really production ready, but it's very convenient, very, very easy to install. Don't need anything. It's just an agent running in my JVM. Let's see if the gods of demo are with me today, are with us today. So first of all, let's see if I have the Dockers open. I have the Dockers in which I have a gallery of things. I'm going to use Postgres. I'm going to use toxic proxy and wiremock runs as a Docker also. Right? That's the parties involved. The services around me, basically. Then I have my application running on port 8080 over here. Good. Which is already, it's a Spring Boot 3 application, I told you. And let me show you the load test. That should be interesting. Let me explain this for a second. It's quick. Why not JMeter? I want to run this on Jenkins. Like, share, and subscribe. Okay? With JMeter, it's a bit more. Can you run JMeter on Jenkins? Anyone runs JMeter on Jenkins automatically in the build pipeline? You, 1 guy, 2 guys. Very good. Well, this thing over here fires. It has 23 threads will fire requests in a loop, like maniacs to my system. Okay. Every time it finishes a request, another one, for 8 seconds. Okay. And I want all the requests to be successful, fun. So let's run it. Application is up, and for 8 seconds, it's going to fire 23 requests in parallel. All right, let's see. And of course, I prepared a bit in advance, so it prints at the end some information that I can just click and see the different things. Let me show you first the report of the Gatling. It says here very nicely here the histogram of the response times, and you have an average of 133 milliseconds. 133, I hope I remember this. All right? And this is a healthy, normal distribution. Healthy meaning not sick. If you ever see this, this is a disease. Okay, it's too much to say. This is not good. The red is not good. The green is good. I'm doing AI training over here. Good, bad, okay? That's why I used red. Okay. But it's a healthy, normal Gaussian distribution that is centered around 133. We're good with this. Now, in the log, I also, by the use of this gatling, which I need to confess, it started, this gatling thingy here, the profiled app, is carefully started with this as a Java agent. You see this? Loaded. So this baby over here runs as is basically instrumented with this glow root, so that it displays this, wow. It feels like fire, isn't it? Yeehaw, baby, look, my God. What the heck is wrapping runnable? Who the heck is Catalina? You know Catalina. It's Tomcat, right? And then Spring, whoa, Spring, of course. And then Victor Training, some filter you did not know about. Okay, welcome to my project. But you see, I don't care about this line because there is no split point next to it. So it doesn't lose. All the samples below it, 157, all the samples below it are also going through above. So in other words, there is no forking of execution. In human words, it does not lose time. Okay? Bam, 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 and we scroll up until the first split point, like I said, here. And we're going to zoom in here to see what happens. I try to zoom like this. Oh, okay. So we have this, where are we here? GDPR. Now, this is how you scare developers today, GDPR. Eventual consistency. Resilience. What else? Meetings. Let's continue the game. So, GDPR, eventual consistency, resilience, meetings. How else do you scare them? P1. Of course. Yeah, but P1 usually comes after a phone call, right? So you first get, yes, you have a P1. All right, so this GDPR aspect that I wasn't aware of is an aspect. Ooh, what the heck is an aspect? And I can already go and search for the class. Right? I'm on a mouse. Shift, GDPR aspect. Now, when the great GDPR war struck, many developers panicked. And let me show you what the developers in this project did. You see, they invented this annotation, visible for, which they used to put on fields of their DTOs so that they can null the field when the user didn't have permission to see the field. Brilliant, isn't it? A round of applause, please. So when the DTO gets out of your system, it gets cleaned based on the annotations. If you are not an admin, you don't see the author email. Huh? Fixed. Quick fix. Good. And the GDPR aspect is doing exactly this. It intercepts all the methods in a REST API, and what it does, it says get annotated fields, and if sensitive fields don't meet the role, blah, 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 they are nulled somewhere in there, using, of course, dark magic reflection stuff, of course. But the problem here is that this causes a hit in my endpoint. So I'm going to look at the endpoint that I'm calling. I know the endpoint that I'm calling. It's called the loan controller. It's called this. The get loan here, this one, am I targeting the get loan? Yes, loan controller get. This method over here, right, returns a DTO that doesn't have any annotation. What a feature. Why don't... Wait a second, and what happens on this side of the line? I can click here. I mean, just before that, I need to show you. On this path, it's the path of the righteousness. There, on that path is the correct path. Getting into the loan controller and further in my code. What the heck happens here? And you have a suspicion, don't you? Socket read. So the GDPR aspect is losing time to do what? Come on, just by looking at this chart, what can you tell? This part here, ending with socket read, what does it do? API call. Where is that? Where is that?
Ooh, what does this button do? Please, please, do not push the button. You have no idea.
Do you see the if? and the fetch. Please tell me, what is stupid in this code? It always calls the API, even if you don't have fields to clear. How to fix it? You don't even need words for this, right? You just need hands. Good. Save. Couple of seconds for DevTools to restart. Run the test again. It's all prepared for you guys here. Up. For 8 seconds of peace and harmony. So this is a GDP. This is an aspect which got lost in transition somewhere there, and now hurts us back on every endpoint. Okay. So the average time right now is 83. It was 123. And the new frame graph looks like this. And you will see this time the GDPR, I'm still going through the GDPR aspect, but what's different? There is no split point, you see? There is nothing here. GDPR aspect doesn't split anything. It's very small, I know, but there is no splitting. Makes sense? So I just avoided the, all right, good. Scrolling up. You're gonna meet something very, very, a good friend of ours. Anyone knows what this is? And don't tell me that this is Spring. No, every single dependency injection framework does this. What is this? It's a proxy. Exactly. It starts with P. It's a proxy. It's a baby proxy. It's a proxy. Good. And that proxy intercepts the call to get loan application that the loan controller did at line 19. So I'm going to go to loan controller. I'm going to go to line 19, and I'm going to see this method here, calling not the loan service get loan application. No. Calling this. Why? Well, because the method that you're trying to call has to be intercepted. Why is that? And you don't need to look much higher to find the guilty. Hello. I have also for this. Come on.
Hello, is it me you're looking for?
Beautiful. What's wrong in this picture? I mean this plus this. To be more exact, this. I don't need a transaction to read, exactly. I need a transaction to change, not to get. So this is put in a junior style at the class level. It's not bad, you're on the safe side until you are struck by performance, okay? So it's a good starting point, but keep an eye on the so what really happens in here? Let's see the whole story. Transaction interceptor splits the execution, so technically the transaction interceptor does not just call my final method here, which is get loan application. You see, this is the method I need to get to. But transaction interceptor spends 60% of its samples, more than half of the time is spent doing what? And I'm going to leave you a bit of time here. And I want to ask you guys, what do you think happens in here? Waiting for a lock, starting from higher, from top down, you see a lock. Starting from bottom to up, what do you see? What? Sorry? Louder. The pool. There is something with the pool. Let's see. Where is the pool? Ooh. What is this? Hikari pool get connection. What is this? It's starving. Wow, the scientific term. He used the scientific term. My project is starving for connection because the GDBC transaction is acquired by the proxy before you enter the method and is released connection after you exit the method. And that's a very bad practice. And it's everywhere, technically. Especially if in that method you do a network call. So, let me spell it out clearly. Avoid doing network HTTP calls in transaction methods. I would repeat that once more. Avoid doing REST, SOAP, RMI, API, gRPC, whatever API calls to other systems, within a method annotated with transaction, or down the rabbit hole in any methods that this one calls in the downstream. There shall not be network calls, because while you wait those 40 milliseconds for the comment API, one of your 20 JDBC transactions, JDBC connections, is dead. It's right there, blocked. And then you starve your application. Your application starves for connection. So how to fix it? The transactional should be closer to where it's really used. I don't need transactional here, but I do need it on the method which talks to the database into saves. You see? Save, save. This one makes sense, right? Also here, does it make sense to put it there? Folks, what do you see that can get you fired? No, I'm exaggerating. In this rectangle. This is something extremely bad. I will give you a hint. The first problem, the first guilty is this guy. Transactional. What is the second big problem in here? Synchronized. What is that? I never saw it for 10 years. What is that? Do not ever do that, because then with a transaction in your hand, you die trying to enter a synchronized method of a singleton. You technically blow up the entire application with just 2 lines. That's called mortgage-driven development. Oh my God, don't do that, okay? So actually, I don't even need that because it's a fine. What the heck, right? So I'm gonna kill the transaction there, build the project, rerun the load test. I'm just sketching some common performance issues. There are infinite number, of course, but just to have a taste how it feels, okay? Run again to see if we find anything else in a flame graph. So there is no more transaction interceptor splitting the execution, you see? There is no transaction interceptor anymore. But now, we look at get loan application. So line 53, where are we? 29, yes, thank you. 29 wastes 42. Let me show you that. I'm going to put here the percentages, right? On line 29, I have lost 42%. 29 is this one. 40% rounded. Then on this line, loan service 28, 40%, 45, 28 here, 45%. And surprise, surprise, on line number 31, 13%. What? Huh? I mean, 1/3 of my time is lost doing log trace. I don't even see the freaking log trace. How the hell is that possible? Any suspicion? No? The toString has to do something with toString. Let me explore this side, the toString part. What do you see? What happens in here? What do you suspect happens in here? Do you see this? Oh shit! It's what? It's a toString? The toString hits the database? How the heck is that possible, right? So let's look at the loan application and let's enjoy this.
My bad habits lead to late nights and in a long conversation. My bad habits lead to late nights and in a long conversations with a stranger I barely know. Swearing this will be the last, but it probably won't.
This is the database. Anyway. You get the point? We have a toString which it's a freaking database. I can fix it in 2 ways. First of all, never put data on entities, please. Getters and setters only, of course. Secondly, this is something from the 90s. We do this today. Both of these solutions fix the problem. All right? I'm going to run it one more time, and we're going to end the coding part. There is much more to this coding exercise. You can look around in the Git repository. It's a lot of goodies in there that you can measure very easily. I think I'm going to show you one more, but let's see the flame graph. Here. One last quick look. This is the HTTP URL connection GET response, which waits for network, feels all right. Approximately what? 40% of time I wait for network. And this is my what? My netpol visible JDBC connection waiting for results from the database. So it's okay. It's like 30% JDBC, 50% API call, and I'm not sure what this is, but maybe if I had more samples, this would go away. I'm pretty sure. But it's enough to get a taste of it, okay? So that was the experiment. What did we learn? We discovered the mysterious aspect, a GDPR aspect, or transaction interceptor, that was forking the execution like this, okay? So we basically see through into the framework's internals. You detect any line of code that gets to run, even if you didn't write it, even if it's magic around you, right? And this is super useful in intrusive frameworks like, I don't know, Axon, like Camel, like they surround you too much and you don't know exactly what happens. It's super useful. Then, we saw a JDBC connection pool starvation issue. You know what I missed to do? I missed to show you the metric. And now I restart the application, the metric got lost. But the metric would have been here, Prometheus, here. The acquire. I forgot to show you this, but Hikari connection acquire seconds. This would have skyrocketed in the case when I had transactional on the class. Proving again that we have a JDBC. The alarm should have gone automatically. Right? That's one of the first metrics you measure when you have a database, the connection acquisition time. Right? Because it's shared. It's only 20 connections shared by everyone. It's a possible bottleneck. This is the actual SQL server execution, and this is getting the connection from Hikari, one of the 20 default connections. And please don't try to increase the JDBC connection port size to 200. I need to say that, right? Because the SQL server is gonna may go. Okay, we didn't see this. We were lucky today, but have you ever heard of JIT before? JIT? Just-in-time compiler. It's what makes Java so fast after it starts. It optimizes the code on the fly, and this is JIT in action. It surprised some raw methods. The right part is what happened when the Java was still warming up, and once it got optimized, the same yellow method got called through another blue one, which is the optimized version of the number one. To cut to the point, when you see this, please repeat the load test on the same instance, because the Java is already optimized. You won't see the right part again. Or it's a good practice to fire up some warming. Any one of you did a micro benchmark before? Micro benchmark, Java measuring harness, that kind of stuff? You have to warm up the JVM a bit. The same thing happens here, right? Or you could just fire more samples, in which case this part over here is going to shrink to very little, opposed to the huge thing that accumulate over here. So it's going to squeeze and not be less important, basically. Synchronized keywords. I did not demo this, but if I would run the sample, there is a local contention test on the Git. You will see an empty space like this. With the execution blocked at the first line of the method. And you're going to wonder, what the heck happens in there? What happens is that your Java is trying to execute the first method, but the rest, the white part, is not in Java. It's a native code. It's a C++ code, and Java Flight Recorder cannot see into native call. So technically speaking, all of the every time you at the top of this flame graph, there are always C++ methods that get out of Java to do low-level stuff in right below GVM. Okay. But by the way, if I would take the Java Flight Recorder and ask it to export me the recording, I would get a GFR file from production that I can load in a tool called JDK Mission Control, And the GDK mission controller is going to tell me automatically, you are stupid. 55 seconds? Are you nuts? Right? So basically, this is looking for some key things, right? And you can download it from there. All the slides are on Twitter. Okay, photograph, but it's a waste. It's a waste of the energy, the planet. Hashtag removal. This is so fun. Do I have time for this? I think this. Let's see. This is a very naive benchmark. Don't ever trust such a benchmark. You have to do something much more professional. It's called benchmark from GMH. Some guys in the room know about this. But still, 100,000 elements in a set, in a hash set, 100,000 elements in a list. And let me do a trick first. Let me remove from the list one element. Remove one element. Let's run this, and I want to show you this also. Actually, I need to click on this screen here. Do you see this? You know what's super cool about this? You can profile your unit tests to see where the time is lost in your long integration tests. So let's run. Straight from IntelliJ. And it's going to show you that everything seems fine. Nothing suspicious here. But what if I don't put this line here? Let's try again. It's already weird. So removing 99,000 from the list takes several milliseconds. Removing 100,000 takes 10 seconds. Do you see this? This is the GFR report straight in your editor. Okay? But I'm not going to go more in this because it's IntelliJ Ultimate. I don't want to. Yeah. So 100,000, if you remove 100, it takes 1 milli. If you remove 99,099, it takes 50 millis. If you remove one more, it takes 2.5 seconds. What the hell is going on? Just GFR this. It will show you that the first green part looked like this. Hash set remove. How fast is hash set remove? Please talk dirty to me. Talk dirty. O of what? O of 1, thank you. The red version does array list contains. Talk dirty to me. Feels like faculty, isn't it? We just stepped on n squared complexity by some weird implementation in the GDK. No one knew about this, really. War story from one of my clients. After such a workshop, they emailed me afterwards, Victor, look what we found. We had an export that we weren't able to fit the proper time. It took 6 days if we actually started. We never started, it's too long. And we were worried about some library that it's the first time we use it, JSON-L. No one heard about that. But by just Java flight recording this program, it showed that Mongo item reader loaded data in pages. It's here, do page read. And with a bit of Stack Overflow, they found Mongo cursor item reader. They used this instead. Result, 3 minutes. What the hell, right? But the problem is they were spending time and brains on the wrong suspect. This was not the problem. You see? It guides you where to look, basically. That's super fun. This, another one. The insert of 11,000 rows took 1 second. Everything fine. Inserting 5,000 rows took 100 times more. What the hell is going on? And then the profiler showed that number 2 was not using some do insert bulk that the first one was using. With a bit of Stack Overflow, they found an issue with inserting in date comments in Microsoft SQL Server. Game over.
Game over.
It's super, it guides you to you can compare the, right? Good. So, what's the best feature of Java 21? Virtual threads. And virtual threads, there is a talk from the lead of the project Loom, who basically explains, 1 hour, explains that one of the key design goals of Project Loom was to be able to use the profiler already built in the JVM. So Java Flight Recorder can see into the virtual threads. This is a picture. I'm not going to explain, we're running out of time. But it's there already, right? I'm going to skip this slide, but I'm just going to say in Java 25, we're going to have this new shiny feature called structure concurrency, which is going to allow threads to link to parent threads. GFR would also be able to see this. So what have we learned? C is inside unknown code and libraries. C does not see into C++. It requires many samples to be precise. Can be used in production, the happy news, the good news. Tuning requires you to have an awareness about the libraries that are in play in your application, right? And if you have super heavy CPU-intensive code, you need to read this article here about biases due to just-in-time compiler, right? Can't follow when you switch threads from one to another, but it can follow virtual threads and structure concurrency. So this is the way to go in Java profiling. So how to find the bottleneck? First, try to repeat the problem with a repeatable load test. That can take 2 weeks. Identify slow system, maybe a Zipkin or some sort. Look at the metrics and expose new metrics after you fix it. Profile, avoid going that deep. That's my point. What I showed you with flame graph is the last resort, okay? And optimize then the code, balancing the noise you add in the code. And with that, I think I'm out of time. I thank you all for your attention, and I will await you to join the community. Okay? Thank you so much.